Good afternoon, everybody. Today, the second part of our basics training concerning the gasket and flange. And I'm pleased to have today with me Hans. Good afternoon, Hans. How are you?
Hello, Laurent. I'm fine. Yes, today we're going to continue with the gaskets. We have recorded our part 1 session, and today we're going to do part 2 of the gasket basic training. So in
Okay.
part 2, in part 1 we talked about what are flanges, the different types of flanges. We talked about gasket material, gasket construction. We talked about different types of gaskets. And today we are going to discuss the stamp method, how to select gaskets, and we're going to look at the core program of Chesterton
Okay.
of gaskets.
Excellent. Very good.
All right, so starting with gasket selection, we use again, just as with the packing, the acronym STAMP. And STAMP.
But Hans, I see that we don't have a S at the end, right?
Correct, you're right,
Oh,
because
I follow correctly the first session concerning the packing.
correct, for the packing and for the mechanical seals we use the stamps method.
Yep.
Because when we are talking about dynamic equipment, rotating equipment, we have equipment that moves, so you have speed. Today we're talking about gaskets, flanges. Flanges are static equipment, so we don't have any speed. Speed is 0, so we cut off the last S. So we talk only about the S, the T, the A, the M, and the P, so stamp. And the S stands for size. We need to select the right size of gasket for the right application. We talk about temperature. The gasket that I choose needs to be resistant to the temperature of the application. Which application is it? Which equipment? Is it a standard flange, or is it something more challenging? Is it a critical flange or a heat exchanger, for example? We talk about the medium. So is my gasket compatible with my medium? Is there a fugitive emission requirement? Etc. And then the last thing, the P, stands for pressure. So the gasket that I choose for my flange needs to be resistant, suitable for the internal pressure of the equipment. So let's start with the first one, which is size. So how to determine the right gasket dimensions. So in many cases, we have to, when we talk about a gasket, we're talking about an ID and an OD. So, and in many cases, if you talk about standard flanges, thin flanges, ANSI flanges, the inner diameter and the outer diameter of the gasket are already predetermined according to a standard. But if you talk about a custom gasket, so for example, in many heat exchangers, for example, the gaskets are not standardized, but they have custom sizes. We need to determine this from a drawing or from whatever a customer gives us. Sometimes what is done is as well the old gasket is measured in order to provide the dimensions of the new gasket. So, but we're not talking only about ID and OD, we're talking as well about thickness. Generally used in the industry is 1.5 or 2 millimeters. That's like the standard thickness that is used in the industry when we talk about sheet gaskets in this case. But sometimes a thicker gasket is used to compensate for a rough flange. If you have a very rough flange surface or a damaged flange, sometimes a thicker gasket is used. If we talk about semi-metallic gaskets, so spiral wound gaskets or Camprofile gaskets, they are usually a little bit thicker. So they're usually around 4.5 millimeter. And yeah, the thickness that is used is per the equipment design. So if you choose to use a different thickness than the one that was used previously, and you change the gasket thickness in a flange that is used in a pipeline, this can actually lead to issues because you can imagine if I apply a thicker gasket and I do this in multiple stages of the pipeline, then at a certain point flanges will not fit anymore in the pipeline. So
Yeah.
that's what we need to take into consideration. And the other thing regarding thickness is that in some equipment, for example, in some spigot and recess designs of flanges, what we talked about in part 2 of this training, they require a certain thickness of flanges to give the right compression of the gasket. So we need to take that into consideration as well. Alright, let's look at the second one of our acronym, the T, which stands for temperature. So every gasket has a temperature limit. It has a maximum limit. So up to which temperature can I use my gasket? And in many cases it has a minimum limit as well. If you talk about cryogenic temperature, many of our gaskets, they have actually a minimum temperature. So the maximum temperature limit might depend on the medium. So for example, if we talk about graphite, it depends on the medium that you use it in, what the maximum temperature limit of the material is. So for example, in any application you can use graphite up to 450 degrees C, but if you have an inert environment, inert medium, where no oxygen is present, you can use graphite up to 2760 degrees. And in steam you can use it up to 650 degrees C.
Just a question. Yep. Does the temperature have the same importance if you consider the dynamic motion, for example, like for the rotating equipment or for the... Finally, here we talk only about gasket. Then the gasket should be not a big parameter, isn't it?
Well, what you actually see is that the maximum temperature of the gasket depends a lot on the pressure.
Oh, yes, okay.
So for many of our gaskets, there is actually a PT graph available. And as well, that usually was done in Europe. The Americans very often use a so-called P times T number. So that's a certain number that that describes if you multiply the pressure by the temperature, it has to be below that number, and then it's okay for the application.
Okay.
So that's what we deal with. So the application, standard application can use a standard gasket. So if we have a standard pipeline, for example, we can use a standard gasket. For example, a standard hot water line, we can use something like a graphite sheet gasket. If we have a cold water line, for example, we use something like a fiber sheet gasket. But if we have a critical flange, and a critical flange can be a flange that tends to fail a lot because of thermal cycling, for example. If a flange is very important to the process, if it can cause safety issues, etc., then we might choose a different type of gasket. So depending on the application, we are choosing the type of gasket.
Okay. Okay.
So then the medium. So the medium is important. Are we sealing a liquid or a gas? What's the pH of the medium actually? And very important is there a fugitive emission requirement? So we have some gaskets that are suitable to seal fugitive emissions. So that's something to consider. So the pH factor is something we consider many times for most of our gaskets. We actually have as well fluid compatibility listings. So lists of different chemicals where you can see if a gasket is suitable or not suitable. And then the pressure. So every gasket has a maximum pressure, and this is different at different temperatures. So that's what I discussed before when we looked at the temperature.
Yes.
So here's the PT graph. So this, for example, means that this gasket can be used up to 250 degrees C. However, if I can use this gasket only up to 250 degrees C if my pressure is relatively low, so let's say up to 10 bars. But if my pressure goes up to 60 bars, my maximum temperature can be only something like 110 degrees. So that's something to consider.
What about the color? Because if I see here we have two kind of blue, does it mean that I have to be in the dark blue versus azul?
Yeah, the on my screen actually this shows up as green and blue, but
Yes.
that doesn't matter. The green, so that's the area here in the middle, is
Yes. Okay.
actually where you're completely safe to use the gasket. And the blue parts, it is recommended to consult with engineering. It is generally okay, but you have to view the entire application. So it becomes more critical at the blue in the blue areas.
And this criteria, this graph, systematically provided with the gasket, I presume, isn't it?
Yeah, on all the gaskets in the European gasket
Yes.
program, we have this graph available. Many of the US data sheets, you see this PT factor.
Okay. Okay. Perfect.
All right, so let's look at our core gasket program. So I'm gonna now take you through the most important gaskets that we have available from our EMEA, or gasket program for Europe, Middle East, and Africa. So, and I'm going to start with a gasket that is called the 455 EU, and this is, let's say, the general service gasket that can be used in all the basic applications that you might find. So, it's as well the most economic gasket that we have, but it has some very interesting approvals. So it has German approvals, the DVGW approval, which is for gas and water in buildings, KTW, which is for drinking water. So these are the approvals that the gasket has, and this effectively can be used in, let's say, the water-based applications and light, chemicals. That's where this gasket can be used. So it has, as I said, it's the most economical gasket that we have in our European gasket program, and they are available as a sheet gasket, but we supply them as well pre-cut in any size you might like. So this gasket actually is available in different thicknesses. So half millimeter, 1 millimeter, 1.5, 2 and 3 millimeters, and the sheet size is 1.5 meter by 1.5 meter. So we like to supply these gaskets in relatively large sheets, so that the cutting of rings from the gasket sheet is more economical.
Okay.
This gasket actually can be supplied. They can actually roll it up for you, which makes the shipping more effective as well, more basically cheaper. Then another gasket, which is as well a fiber sheet. This fiber sheet with an MBR binder is somewhat similar to the 455 EU, but where the 455 EU has only aramid fibers, this is actually a mixture of aramid and glass fibers. So this is actually a very high performance fiber sheet, and it has as well a lot more approvals than the 455 EU. Hence, it's a little bit more expensive as well. So it has the DVGW, it has the KTW, but it has as well, which is very interesting for being able to use this gasket in, for example, refineries as a utility gasket. It has a fire approval. So what does it mean that it has a fire approval? You can actually seal flammable liquids with this gasket in a refinery, for example,
Mm-hmm.
and it has been tested that in a way that it can withstand a fire. So it can actually be used in refineries. And then as well, it has a TA Luft approval. TA Luft is a German emission standard, and this gasket has the TA Luft approval. So
Question: environmental gasket means ecology gasket?
yes, that basically comes from the fact that it has a TA Luft approval.
Okay.
So it can actually be used to keep the environment free of hazardous compounds. So it is an environmental gasket. So it works actually in steam, chemicals, and as well hydrocarbons. It can be used in a refinery as a general service gasket, and it has relatively high temperature and pressure capability. So the temperature limit is up to 450 degrees C, which is relatively high for a fiber sheet, and pressure it can withstand is 120 bar. So it's as well supplied in the 1.5 meter by 1.5 meter sheets. And yeah, it's, let's say, the premium product next to the 455 EU. So then, besides the fiber sheets, we have a number of graphite sheets, and the first graphite sheet I want to show you is the Duragraph F. Duragraph, the name basically stands for graph from graphite, and dura from durability. So it's a durable graphite gasket, and the F here in the Duragraph F stands for foil. So that means that this is a graphite sheet which is reinforced with a flat stainless steel foil. And this foil is 50 millimeters, not millimeters, micrometers thick. So that means that this sheet can be cut by hand because of the flat insert and the relatively thin insert. Excellent at higher temperatures, excellent chemical resistance, as well available as pre-cut gasket and as well as a sheet. But as you might note here, the sheet size here that we chose for this gasket is 1000 by 1000 millimeters, and this is actually because this graphite sheet has to be shipped flat, and because this gasket is basically the gasket that we have in our program to cut by hand, we supply it in a smaller sheet so it can be easily managed in a workshop.
Okay.
So maximum temperature 500 degrees C, maximum pressure 100 bar, and it has a DVGW approval and a BAM approval, which is the oxygen approval, German oxygen approval, which is actually required in a lot of paper mills as well. So besides the Duragraph F, we have the Duragraph T, and the T here.
Graphite, durability, and T for temperature?
T stands for tanked.
Oh.
And tanked is, again, just like the F, it relates to the insert that is used inside the sheet. So tanked actually means a flat foil that has been perforated from both sides. So you get these little, let's say, hooks in the foil, and this is the way that the graphite is actually bonded to the insert. The Duragraph F, the flat foil of the Duragraph F, is actually glued to the graphite. So there's some glue present in the Duragraph F, but the Duragraph T, there's no glue present. So it has a much higher purity than the Duragraph F.
And then I see that the insert are 100 micron.
Yeah, so this insert is a little bit thicker.
Yep.
And because this insert is a little bit thicker, it's impossible to cut this by hand. So this really has to be cut on a machine, and that's why it's the best to supply this gasket as a pre-cut gasket. So you don't really want to order this sheet to cut it yourself in a workshop, because that will not work.
Okay.
So this is basically a gasket that has a number of approvals. That's the DVGW again, the KTW for the drinking water. It has the BAM approval, and it meets as well a shell spec, the SPE 85203, which relates to the purity of the gasket, and it conforms to that spec as well. Temperature resistant 120 bar, sorry, temperature resistant 500 degrees C, pressure resistance 120 bar. Okay, and available in 1 millimeter, 1.5, 2, and 3 millimeters. Where again, the standard thicknesses usually used in industry are 1.5 or 2. Depends a little bit on the customer.
But it's not TA Luft approved, right?
No, we don't have a TA Luft approval for that gasket.
Okay.
However, we do have a TA Luft approval for the ECST, and the ECST is a PTFE sheet gasket. The PTFE sheet gasket in our European program. So that means that this is actually the gasket that is used for basically where you have a high chemical requirement. The gasket sheets, of course, they have a pH range from 0 to 14, but they are not so so good in some oxidizing environments. So the ECST is actually the gasket to use in chemicals. So very high chemical resistance, excellent in strong acids, where graphite in some cases is not so good. ECST is perfect. And again, it's available as a sheet and as well as a pre-cut gasket. So this is actually a modified PTFE with a silicate filler.
If I remember, Hans, if I remember the first session, we need a filler in order to bound or to increase the property of the PTFE, right?
Yeah, exactly. Pure virgin PTFE has a very poor mechanical characteristics. It suffers cold flow.
Yes.
So in this case, this gasket is actually built up of different thin layers of PTFE. So actually, it's been rolled and then multi-directionally put together to increase its mechanical characteristics, and it's as well filled with a silicate filler, which makes it a very stable gasket that doesn't suffer from cold flow.
Okay.
So again, the sheet size that we have is 1500 by 1500 millimeter. Actually, the thinnest gasket of 1 millimeter is only supplied in 1.2 by 1.2 meter. Temperature, as most of the PTFE products, 260 degrees C. Pressure resistance 85 bar. Standards and approvals, FDA approval, so it's actually food grade. Besides the FDA approval, it has as well the EC 1935 approval. So that's a new regulation concerning the use of different seals in the food industry.
Yep.
So it complies with this regulation, and as well we have a TA Luft approval, as I said.
Okay.
And then, besides these sheet gaskets, we have a number of semi-metallic gaskets. We explained a little bit how the different semi-metallic gaskets are constructed. Let's look at the spiral wound gasket. Spiral wound is basically a gasket. It's pretty old technology. It works well though, and it's as well the most economic semi-metallic solution. And we basically want to apply our spiral wound where the customer uses currently a spiral wound. We don't want to use this as an upgrade. We basically sell this as a like for like type of product. We have them in DIN size, we have them in ANSYS sizes. We can do as well custom sizes. It has as well TA Luft approval. So we have that. Maximum pressure 350 bars, and the temperature depends again on the sealing element that we use. Spiral wounds can be supplied with a graphite sealing layer, can be supplied with PTFE sealing layer. We have the option as well to put some more ceramic type materials in there. and the temperature resistance of the gasket really depends on the sealing layer that we use.
What is the thickness of this?
Standard thickness is 4.5 millimeter.
Okay, yeah. Compared to the okay.
And there are some different thicknesses available as well, but the standard is 4.5, and it's not 95% of the gaskets we supply have this standard thickness. So then we have the cam profile. This cam profile is a pretty high-end gasket, very high reliability, high performance. It actually needs very little sealing stress to seal. It's very hard to over compress the gasket, so it has a very high range of operation. Low emissions performance, so it has the TA Luft approval again. We can supply this in DIN and ANSI gasket shapes. We can do custom shapes, and we can supply this as well as heat exchanger gaskets, so that means ring gaskets with a crossbar. Materials are again different types of stainless steel or different types of metal, and as well again we can supply this with a graphite or PTFE sealing element. Applications: pipe flangers, heat exchangers, basically any type of application that you might find. We apply this actually a lot on heat exchangers. Pressure resistance up to 400 bars, and again the temperature resistance depends on the sealing layer used. The steel trap gasket we touched as well in part 1 actually. Similar performance as the cam profile gaskets, but where the cam profile is a standardized material that is basically supplied by multiple suppliers, the steel trap is something specific to Chesterton. So that's something that more or less only Chesterton can supply, so you have something to differentiate yourself from the customer. So the big.
But in this case, how can I choose between the cam profile and the steel trap? Which is because both are metallic gasket, right? It's more on
Yes.
Because of shape or.
Well, first it depends on the thickness. Many cases,
Okay, yes.
if we want to replace for example, if you want to upgrade a spiral wound gasket or a metal jacketed gasket that has a certain thickness, sometimes there are limitations from the equipment where we cannot change too much the thickness. So that's where we really want to go to a cam profile gasket to avoid those problems. Steel trap gasket is actually excellent to replace a sheet gasket and upgrade a sheet gasket to a semi-metallic gasket, because the steel trap gasket actually has a very thin design, so it's only 1.6 millimeter thick. There are different thicknesses available, but we can supply this in a very thin design. So as we seen as well in part 1, the thicker a gasket, the more grip, let's say, the more force the internal pressure can put on this gasket. And
yes.
that's one of the advantages of this thin steel trap gasket, that the pressure cannot exert a lot of force on this gasket. So it increases actually the reliability and the blowout resistance.
Okay, it's just very because now I understand one thing. In the first section, when you in the first video, and I invite you to watch this video, you explain the pressure blowout and the hydrostatic pressure inside the pipe between the flanges, with the tendencies to increase the space and to work on the bolt. And then you explain the effect of the blow up to go due to the pressure inside. And now I see one important thing, that more the thickness is small, less we have surface in contact with the pressure, and then we have effect to destroy the joint, the steel, and the seal, sorry. And if you compare with the cam profile and with the spiral round gasket, which is very 4 millimeters, you said. Then this is because it's thinner, it will be more capable to resist on the high pressure and high pressure variation. I'm right?
Correct. Yes. Completely correct. And then, actually, another nice advantage of this gasket is as well. This is basically we can basically make any shape of these gaskets, which you can do as well with a spiral wound and a cam profile, but it's much more complicated with those type of gaskets. We can actually cut, for example, a heat exchanger gasket from one piece of metal sheet. We can as well laser cut this type of bonnet seal very easy from one piece of metal sheet. So there's no welding, which is happening in both cam profile and spiral wound gasket. There's some welding going on, so we can completely do this welding free. Another nice advantage of the steel trap gasket is actually that it seals very, very well at low pressure, low stress conditions. This is actually a big advantage in man-way sealing, where a gasket is continuously being unloaded, and actually this gasket, when the pressure has been, the stress is taken off the gasket, it keeps sealing very, very well. So that's another nice advantage. So we can make this from virtually any metal that is available in sheet form.
Yep.
And we can add a graphite sealing element to it, a PTFE sealing element, or we can add a ceramic type of sealing element to this.
Yes.
Used practically any flange, but very nicely can be used in heat exchangers, valve bonnets, housings, critical flanges in general. Has a TIA lift approval, so very good sealing performance. Pressure up to 450 bars, and temperature again, depending on the sealing element that is used.
Another question, Hans.
Yep.
For the sheet gaskets, you say that all the sheet gasket could be available also as cut gaskets. I see that here, this is another topic for the metallic gasket. It seems that we have to order, and some of them can be manufactured on demand, and as for example the C-trap in any shape. Question: how can I order the cut gasket here in Europe, and how can I or what is I'm just really thinking to a new specialist, okay, which follows this nice video, and now is very exciting. It sees that we have a different program. Packing is easy because one item numbers and it's done. We can at least the sheet gasket, it's an ID that we can also order. But if I want to order a cut gasket, or if I want to order steel trap, for instance, how can I do?
That's actually a very good question, because all the gaskets from our European program can be ordered from Munich, from our Munich office, with one exception, and that's the steel trap gasket. The steel trap gaskets can be ordered directly from our manufacturing location, which is Sealing Corporation. But let's get back to the sheet gaskets and the cam profile and spiral wound gasket.
Yes.
You can basically order this by giving the dimensional information of the gaskets, the material information, and if you don't have dimensional information, you can order this by the pressure class and the pipe size. So we have some, in case this is an issue, we have ordering forms for the gasket where you can very easily fill out all the data that is required to order a gasket.
I think, Hans, that we can announce that the last version, the latest, the next video will be how to order sheet gasket, how to order steel top gasket, and I'm sure that it will be very interesting presentation for all our specialists to understand how we can now order, because it's one thing to understand the basic, it's interesting to understand the core product, but now we have the next step. We are not here to here to do business, is how to order and what are the procedure that we have to use to order the different product. I'm right, Hans?
Yeah, good idea. Excellent.
Very good. Makes sense.
Okay, and I don't know if you have any other questions, Laurent, but this basically brings us to the end of the basic training for flange gaskets. Do you have any other questions that you want to ask?
No, I think it's okay. I always say thank you very much for this very nice presentation. Again, for everybody who want to know more about the product, more about the basic training. Remember, we did the basic training for the packing. We did this basic training for flange and flange gasket, and I would say all the stationary and rotating basic training are done now. And if you have any question, you can always send an email to Hans, to me, or to contact directly your customer service. Thank you very much. Bye-bye.
Thank you. Bye.
Bye.